Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. I want to do something a little bit different this week. We're going to solve a problem as well, but I had an idea a couple of weeks ago. It's sort of a novel approach to something, and I tried it out, and honestly, it far exceeded my expectations. But I didn't share it with you guys. I kind of set it aside, and I thought, you know what, I'm going to wait until I have a functional print that requires this. But I don't want to wait. I want to share it with you guys because I think this is something that could be incorporated into so many different designs, and I haven't seen anybody else do it. And it builds on some of the stuff that we've done here on the channel before. So in a couple prints in the past on this channel, we have used PLA as an interface material for TPU prints. We did that big TPU grommet, and we used PLA for the interface layer, and it came out super clean. And that, in combination with a couple of other prints we did, gave me an idea. I thought, you know, what if we had alternating layers of PLA and TPU to basically form a TPU bellows. And this was actually the very first print that I tried this on. And I want to point out the interface layer was black PLA. I specifically chose white TPU and black PLA so that we could very, very easily see any mixing between the two. And that is a prerequisite of this. You really do need a machine that has 2 or more tool heads to do this. Any amount of mixing between the PLA and the TPU pretty much voids the properties of each material. So I did this on the Bambu Lab H2D. And this is, believe it or not, this is a single layer of TPU. And each one of these was separated with an alternating layer of PLA. So there was a layer of PLA here, layer of PLA here, alternating back and forth. And you can kind of just flex this and break out those pieces of PLA. And there are, it's like maybe a few spots here. There's one right there where you can see a little bit of PLA that got stuck in there, but you know, again, this is white TPU with black PLA for the interface, and this guy is really clean. And look how flat this is. I mean, it's maybe 2 millimeters thick. Now, it was a little bit taller. You know, I'm squeezing it all the way down, and the interface layers aren't on there. So if we look at the edges, that gives you about what the true height of this print was. But, I mean, look how big this gets for such a small print. And this is quite durable. This is Sane Smart white TPU. It's actually a little bit translucent as well. 0.2 millimeter layer heights with 0.2 millimeter PLA in between. To try and make this even more durable, I thought, okay, well, I'm going to stick with a 0.2 millimeter layer height, but let's let it do 2 layers of each, because for support, you still end up with a top and bottom interface layer. We just don't have any actual support in between. So this printed the exact same way. Layer TPU. 2 layers of TPU to form one section, 2 layers of PLA, and alternating, and we still end up with pretty much the same concept here, except it's very durable. I probably, well, you know what? Let's see. I actually can't separate that. Yeah, just so you can see how hard I'm actually pulling on this, let's grab the ends. I honestly cannot separate that. So as I mentioned, this is Sane Smart TPU. I tried this with TPU for AMS, mainly because it is a little bit of a pain to feed TPU on the H2D. And that brings us to today's problem. But before we get there, so here is TPU for AMS, and you can see this completed. And I used PLA for the interface layers here as well. You can see it does seem like the PLA stuck to this a little bit more. You can see the black residue on there. But you can see it's already torn there in one spot. So I'm going to do the same thing. I'm going to grab the ends of this and I'm just going to pull. Let's see what happens. Yeah. TPU for AMS, I mean, yeah, it's better than, it's nice that you can feed it in the AMS. It does not bond well together. I guess that one didn't tear at the layer line, but no comparison to, you know what, let's take, where's the really thin one? Yeah, here's the really, really thin one. Let's try and destroy this one. This one I'm sure will tear. Wow, that held up way better than I expected it to. It did ultimately tear at what looks like probably a layer line, but that held up really, really well. And that one looks like it tore at a combination of the layer line and the beginning of the layer. Like this TPU is really, really durable. So hopefully just that quick demo kind of gets the gears turning in your head for all of the different possible applications of this, because it doesn't have to be just a little test piece like this. This could be in any shape that we want, and it doesn't have to just end in a thin piece. I mean, we could have like mounting blocks in the end of this. This could be incorporated into like a whole print in place design. And it doesn't take up very much room on the bed at all. Again, it's printed in this orientation. So if you imagine, if we filled the entire volume of even a smaller machine in the Z with this, heck, we could probably stretch this thing out to several meters in length with one print. So I want to take this to the next level. I want to try doing some actual test prints with this that are in more useful shapes than this. Unfortunately, I don't have any more of the SaneSmart TPU that I did these tests with, but I do have some Sunlu white, but we've got to solve a problem first. So this is my AMS HT, and this is normally connected to the second nozzle on my Bambu Lab H2D. And normally, if I'm printing regular filament, you know, like PETG, PLA, whatever, non-flexible filaments, it feeds through the PTFE connection down here that is fed through the motorized feeding system in this AMS unit. They actually provide a second connection up here, and if I angle this, you can see this is really just a rubber plug through this polycarbonate. And they want you to feed TPU through here, bypassing the drive system on the AMS so that it will still feed without issues. It just basically gets drawn by the extruder rather than going through the normal AMS feed and buffer system. And you actually have to make a change inside the machine as well. You've got to disconnect the PTFE tube from the buffer for the second nozzle and run it out of a separate hole out of the back of the machine, and then connect it via a little shorter PTFE length. And that feeds, so one end goes in here, and that's exactly how they show it, inserted through like that. And in fact, it's actually got a little angle. It likes to sit like that because your roll gets inserted so that it's unwinding in this direction. So filament's coming off the roll and going up through this PTFE tube. And then I just connect this through to the little nub that sticks out of the back of the machine to that second nozzle after it's disconnected from the buffer. The problem is, and this is not unique to Bambu, this is the same problem I've had with all of the other filament dryers that I have used that have just this little sort of, you know, rubber plug for feeding the PTFE tube. The PTFE tube is a reasonably tight fit in there, but it's not tight enough. So what happens is, when it's feeding the filament, it actually ends up drawing the PTFE tube deeper and deeper and deeper into here until the PTFE tube itself starts to wrap around the filament roll. Because it is feeding more filament in, but it's actually sucking this guy in too. And it doesn't always happen. It happens, I'd say, about 50% of the time. And what I've been doing to avoid that is I don't actually put the PTFE tube in. I just kind of leave it out here because there is a bit more force required to push this in. So I kind of just leave it out, and it kind of dangles right about there, and the filament then feeds this rubber piece. Problem is the filament is eventually going to wear down this little rubber plug, and it's also not coming out at the ideal angle now because it tends to kind of dangle like that. So that filament has to make, you know, like a 90-degree turn to get into the PTFE tube. So I think what I want to try doing is designing something that clamps this PTFE tube in place. And I actually already took a quick pass at this. I created this guy just thinking, well, you know, I'll just make a little block that's easy to hold on to and make a really snug fitting hole through the block that keeps the PTFE tube in place so that it can't pull through this block anymore. And then I'll insert this in here, and I even angled it. But the problem is, if you haven't already guessed, it's way too loose of a fit in this. I designed it at exactly 4 millimeters, figuring I'll drill it out with a 4 millimeter drill, which is what the OD of the PTFE tube is. So I get a nice tight fit and push it through. Again, that's why these sort of little nubs are on here, so I can hold on to this guy. And I figured it would stay in place. Well, that didn't really work out. I drilled this out with a 4 millimeter drill bit. That wasn't big enough. It was close. I could kind of get the tube started in there, but not enough. It was, you know, bending. So I thought, all right, well, I'll drill it out to the next drill bit size that I have, and you guessed it. Now it's a nice slip fit, but there's very little, I mean, it stays in place on there, but there's not enough tension that it's doing anything more than what our rubber plug on the back here already was. So this isn't going to work, but I've got some ideas for how to design something almost as simple as that, that'll clamp down with a couple screws. Also keep us at the right angle so we have a better filament feeding path for the TPU. And I think this idea should more or less work for not just the AMS-HT, but also any of those filament dryers that you can print directly out of that incorporate this style of rubber plug. All right, I'm going to get some measurements from the back of this, and I'm going to start drawing something up, and I'll bring you guys back. All right, and here is the design that I came up with for this. And it's designed in two separate pieces. It's two halves that will go together. I've got a bevel down here on one side just to make it easier to insert the PTFE tube if this is already bolted together. And there's two holes on this side for nuts, and they should be retained in there. I tried to get the fit just right so that they're kind of like a real light press fit. You can just do it with your hands, but they won't fall out. And then this side is where the other end of the bolt will go through. And once this is put together, it should clamp down on that PTFE tube. So the idea being we can extend as much PTFE tube out of the top here as we need and then clamp this in place. And it should hold the PTFE tube in that position. And then this top part is angled so that when I put these two halves together, the angle of this face here should basically match the angle that that little rubber connector wants the PTFE tube to go in to maintain the correct filament path. So again, pretty simple, but this should get the job done. All right, our print completed and everything looks nice and clean on here. I guess you could see if our PTFE tube fits in there. Yeah, I mean, just me pressing down on it with my thumb and forefinger doesn't give us enough clamping pressure, but it's not a loose fit when I squeeze it. The tighter I squeeze, the harder it gets to move it. So I think we're probably at the right size, or at least close to the right size. Let's see if our hardware fits. Now, I designed this for M3x12. I will put a link to this kit down in the description of the video. I've used a bunch of these different kits here on the channel before because there's just so many styles of these little hex bolts. This is they call it button head cap bolts. All right, I figured we could just press these in by putting the nut on the end of the bolt and kind of just pushing, but it's actually a completely loose fit in there. So I probably want to tighten that up a little bit because this is going to be a pain to assemble trying to hold the nuts in there while we put the bolts on the other side while holding both halves over the PTFE tube, but I think I can probably manage to do that once here just to test the rest of this. These are 2 millimeters internal, by the way, for those cap heads. Okay, that's one side on. Okay, so I tightened those until they firmed up and then I backed them off like half a turn. And this is yeah, it's a nice sliding fit on there. So we probably want about that much sticking out. Let's snug these up now. Yeah, it's not bad. I am able to slip it on there. I don't know how much force gets generated by the extruder when it sucks this guy in. I mean, I got to push on that pretty hard to move it, but we might want to tighten it up a little bit, but let's just try it on here. Okay, yeah, it sits on there nice, and it gives us the right direction for feeding in. I don't really like how this flops around. I mean, there's no way, and if your PTFE tube is coming from above, I think it's probably going to hold that angle. Yeah, it holds that angle really well. But if your PTFE tube is coming from the side or from beneath, which is where mine's coming from, it's not really going to stay in place. All right, I'm not super fond of the fact that I can still push this on the PTFE tube if I push hard enough. I don't like that our little nuts in there don't stay in place on their own. And I'm not a fan of how this guy flops around. I've got an idea to solve all three. Let me go implement that quick. I'm going to print another one. I'll bring you guys back. All right, our next iteration is completed, and I think I solved for all three problems I mentioned, and one more that I hadn't really thought of until after I turned the camera off last time. So here's our original one. I don't know why I had this, this round section coming out so far. I think I extruded this up and then sliced it at the angle I needed and then never shortened it back down because there's really no reason for that to protrude out that far. We really only needed to protrude out just far enough to accommodate this angle. So that's the first thing I did on this one. I just brought that geometry down so that the lower part of the angle sits just above the flat face here. We should have a nice fit on these now. I brought these in, I think, 0.2 millimeters, which doesn't sound like much, but I bet that does it. Oh yeah. Oh, it's perfect now. Yeah, you can see that guy locks in there. It's not going to come out, but I don't need a press to put it in either, so it solves that. The next change is very small here. It's actually, yeah, I can see it through the screen on the camera here. I think you guys can see it too. Can you see sort of that little protrusion there inside of our path for the PTFE tube? I'm hoping that that bites into the PTFE tube just a little bit. That's only sticking up by 0.2 millimeters. So not very much at all, but it should be just enough to give us some extra clamping pressure right where the screws are. If you notice, I lined that right between where our bolts are going to go through to give us the maximum amount of strength on that bite. And the last change I made is this hole right here. It doesn't go all the way through. I'm not going to tell you what that is yet. Some of you can probably guess, and I'm not sure it's exactly in the right spot myself. We're going to find out. Let's get this together. All right, that is on there really nice now. I can't get it to budge at all, and I also can't rotate it. That little tooth, I didn't even think about that. It also kind of locks it from rotating, so you can get this in kind of the position that you want it to be, where everything wants to naturally sit in your setup, and then lock that down in place. And you should still have the right angle. Yep, you can see that that filament path is at the right angle. And now, remember that little plug there on that rubber piece? It should fit into this hole that I added. And there we go. It is tricky to get it in there, but that's kind of the point. We don't want it to slip out either. And I did actually make that hole a little bit bigger once you clear the opening, so it actually expands a bit inside to make it even harder for that to back out. Now, you can remove it when you want to remove this, but that pretty much locks this in place so it can't slip out, and also holds it at just the right angle. So I'm very happy with that. All right, now that we've got that problem solved, I'm going to go reconnect this to my Bambu Lab H2D, and let's get back to messing with this idea for the TPU bellows. I want to try actually doing some real shapes with this and see if this idea still works. All right, I finished a bunch of testing. Let's take a look at the results, because I've definitely learned some stuff. So starting with this one, this did not go too well. I discovered that the Sunlu TPU is actually more transparent than the SainSmart stuff and feels a little bit different. It doesn't seem to adhere to itself quite as well either. Now, I want to point out, I've never encountered that as an issue on any of the TPU prints that I've done. Like this isn't something against Sunlu filament. These properties might actually be better for solid TPU prints than the SainSmart stuff. I don't know, but it does seem like the Sunlu TPU isn't quite as good at this application as the SainSmart stuff. This was printed with, I think, one line width where the layers join each other, and that wasn't enough. It just sort of tears apart. You can see here. So that tears apart way too easily. That should not be doing that. So I reprinted that actually a little bit smaller with two line widths, and this one did complete and honestly came out pretty nice. But you can see there's a couple spots there where it's tearing. And I tore a couple here just removing the support material from inside. It's not difficult to get the support material off of this. It is a little time consuming. And I didn't intentionally try and separate these, but let's just try. Yeah, I can tear that with maybe 15 pounds of force if I had to guess. Once it gets going, it's a little easier, but yeah, 10, 15 pounds of force it takes to tear that apart. And, you know, that's not the best. Yeah, so if I yank on that, we can pull this all the way apart. So, yeah, I think we need more line width, but I still think this was a pretty good test of this. And again, I mean, look how small this is. Yeah, sure, it actually occupied about that much height on the bed, not what I can squeeze it down to in the center. But still, imagine if we printed this all the way up to the maximum Z height of the printer. Like this thing, again, would be several meters in length. It'd be absolutely huge. The next test I did was the round one. And I've actually got two here. There's nothing wrong with this one. I thought there might have been something wrong with it, and I restarted the print because I got an alert from the printer, from the AI, that it was detecting air printing. And I couldn't tell for sure if maybe it had missed the PLA layer on top of this, but no, I don't know if it's because this filament's white or because it's partially translucent. But the AI camera on the tool head of the H2D really thought that this was failing. and I canceled it and restarted it. It wasn't failing at all. This prints just fine. And this is 3 line widths of overlap with the Sunloop TPU, and I don't think I can separate that. Yeah, now that's really on there. So I reprinted it, same exact settings, and I actually got the same error, I think on the second. It wasn't in the exact same spot. It was maybe one more layer up. I got an alert that the AI had detected error printing, and I just hit continue because there was nothing wrong with the print. And it actually finished the rest of it then without any further errors. But this came out really nice. Now, this is not the ideal geometry for this. I think there'd be a better way to design this that gave us more flexibility, because particularly with the circular one, as I stretch it, it's really trying to shrink the circumference of the taller, or the wider sections there. So as I pull this, it actually takes a fair amount of force to pull this apart. So I think there's probably a better geometry for that. But again, imagine this, if we maxed out the Z height on the printer, this thing would be, you could actually make your own flexible hose with this. And I don't think I can separate this. Let's try. Nope, I can't. You see, it's deforming it a little bit, but I bet that all goes right back together. Yeah. Yeah, comparing this to like the strength of commercially available flexible hose with like the steel coil inside, I don't think I could pull that hard on that stuff without it tearing apart. And I cannot separate this. I'm genuinely not strong enough to pull this apart. So I want to do one more test with this. I want to try, I thought of one application for this would be like way covers on sensitive equipment that you don't want to get any dirt in there. And normally those are quite expensive to buy. And if the piece of equipment that you want to buy it for has been discontinued, getting custom ones made, you might be looking upward of $1,000 just for one small way cover. Let's try doing one that would be sort of a fit for my small lathe. Before we do that, I want to take a minute and just make a quick announcement for the channel. Over the last couple of years, many of you have reached out and asked if I would please create a Patreon so that you could show your support for the channel. And I've always been really reluctant to do so. It just feels a little bit weird to do. But I'm not entirely sure why, because I myself have joined the Patreon over the last couple of years for several of the creators that I really enjoy seeing every week. I just feel like I connect with them, and whatever it is that they post, I know I'm going to enjoy seeing it. So you guys asked for it. I want to give you guys the opportunity to do that for this channel as well. And I think I even came up with a clever name. So I'll put a link to Patreon down in the description of this video, and I'll also add a link on the YouTube channel page and on my site fpfdesigns.com as well. And I've named the Patreon member levels Over-Engine Nerds. I thought that was kind of funny, since you guys are always calling me out on over-engineering things, and you're 100% right. I don't deny it. So you're going to see 2 different levels here. And the benefits of each one is the same, other than the moniker for the first 100 people that join. You'll be listed as a founding member. But again, the benefits, match between these 2 levels. They are the same. And the benefits that you're going to get are, you guys know, I give away the STLs for free for all the designs that we do here on the channel. And that's not going to change. I'm not going to charge for STLs. But I often get asked for my source design files, like my workspace in CAD, as well as all the settings for the prints that I do, like all of the project settings in whatever slicer we used that week. So that is going to be 2 of the key benefits. If you join the Patreon, you'll get access to my SketchUp files. And if I move to a parametric CAD program in the future, you'll have access to those files as well. Which brings me to the other benefit here on Patreon. And this is the one that I'm most excited about as well. I would really like to connect with you guys as I'm working on the videos each week. And that might not always be practical, depending on what the video is about. But like, for example, messing around with the TPU Bellows, it would be really cool to be able to share some pictures, with folks that are, supporters of the channel, and be able to get your feedback and suggestions and incorporate those potentially into the video. So I'll be doing that each week as I develop the videos. Again, as long as the content, permits that. There's some things that just won't be practical to do, but I'll probably share pictures as that week's design is coming along, and ask you guys for ideas, like how would you do this part, or can you think of a better way to do this? We tend to do that a lot in the comments today, and I hope that doesn't change, but I think it'd be neat to be able to get more input and share a lot more with what's actually going on in the designs as I iterate through them. All right, enough about that. Whether you come up and take a look at the Patreon or not, thank you so much, everyone, for all your support in helping build this channel. I really, really appreciate it. All right, so here is my workspace up to this point, including the new test that I want to try for these TPU bellows. And this is not as hard as you would think to draw. You only really need to draw the profile. I've had a couple different iterations of that here as we've moved along, but this is the most recent version of the profile that our next test is going to use. So you can see here, this represents the TPU portion of this. So we have TPU, this is where it's joined together. So this would be a layer here, this would be a layer here, and the rest of this layer would be support material. And then we're back to another layer of TPU, and it joins together on the other side. And you can kind of see as you stretch this apart how it would form. The reason why I start with just sort of this little nub kind of on the end down here, TPU, even with alcohol, is a little bit difficult to remove from the bed. There's just no reason to fight with it. So if we make our first layer PLA, or our support interface material, it comes off the bed a lot easier. Now, on the test print that I want to do, I didn't actually end up doing that because I thought, you know what, let's actually make solid sections for the bottom and the top, because if we were going to use this for kind of what I'm intending to try it for, we would need some solid sections for mounting hardware. And I don't anticipate there's going to be any problem with doing this, but I mean, we haven't done it in any of the tests, so I figured let's give it a go. And this width here is approximately the width of the ways on my small metalworking lathe. So it'd be fun to kind of see how this fits over that. But yeah, I mean, this profile here is pretty much the same one that you saw. And then I just drew the shape that I wanted and then essentially did like a revolve around that shape. And it, you know, CAD draws all of the actual hard geometry for you. And you can see in here, here's the other tests that we did. So the earlier tests were from these. I just shortened the length because there wasn't any point in making them that long. This was the shape of that failed one that just didn't have enough overlap. And these were the last two that I showed you. So let's go ahead and print this one out. I'm excited to see how this works because we have nice curved surfaces. That should also make the supports a little bit easier to remove. And I want to see how this fits over the ways and if it would be practical for that application. All right, our print is complete, and I didn't post-process this one. I left it exactly as it came off the bed on the printer, so you guys can see what this looks like, and it's quite dense. Part of that is because we have these solid sections here on the end that the bellows should still be attached to, but part of that is just because everything's still stuck together. The TPU and PLA do stick to each other, just not enough that you can't pull them apart. In fact, if we, I think one end I already pulled on a little bit, yeah. So this end you can see still actually. You can see how easily that separates. And you've just got to go in and pull out the PLA from each section. Like I said, it's not hard. It's just a little time consuming. Once you get one started, you can get it out of there pretty easily. I'll do like 2 sections here on camera, and I'll do the rest off camera. So that was the one that was between these 2 TPU layers. Now we need to swap over to the other side and just get a hold of the edge. These usually come out in one piece. And there we go. That is that whole first section process. So I'm going to move the camera over to the side, and I'll just speed it up, and I'm going to get the rest of this processed. All right, all those supports are out, and take a look at that. Not sure exactly how far I can stretch this guy out to, but I mean, considering how flat it is, now keep in mind, I mean, there's 5 millimeters of solid material here on each end that this is attached to, and it still goes down to that small. So you don't require much clearance at all to install one of these. But look how big that is. That is awesome. Let's see if this actually fits on the ways of my small lathe. I kind of roughly dimensioned it around that just to see if this was going to work. All right, and as a reminder, I didn't really design this to mount on this machine. I just designed this to be roughly the width of the ways to clear. If I was really going to design one of these to mount on this machine, I'd probably try and take advantage of the existing mount points. There's at least one hole here in the casting for the head, and we could probably use the holes that we previously mounted these TPU way wipers that we designed for the other end. But let's just see. Yeah, take a look at that. That would 100% work. I think it would have to be probably twice as long as this. I don't know. Let me move this all the way over. All right, this is my smaller 10 by 22 lathe. This is the carriage all the way over. If I kind of stretch it out. Actually, that darn near makes it as is. I probably would make it twice as big as this just so there's some extra play in it. We're not stretching it out to its maximum. But even if I do stretch this out to the point where it is starting to distort, it still goes right back together, which is, I think, the biggest difference between printing a Bellows and TPU like this versus printing it in its already expanded shape, because you're never going to get it to go down to anywhere near that flat. But you still get, if anything, even more expandability of the material because those layers are so thin. And you can vary them. I mean, this is 0.4 millimeters thick, and this Sunloose stuff is fairly translucent. But we could make these a millimeter thick or 2 millimeters thick if we wanted to. Now that is going to cut down on how small it breaks down to, or how small it flattens down to. But yeah, I am genuinely impressed with that. So hopefully seeing me demo this handful of examples gives you guys some ideas of how you could be incorporating this into your own 3D printed designs. I mean, I think we're truly just scratching the surface with this. I mean, I could see this working as a light diffuser for a lamp or for like a flashlight. I could see retractable covers for parts of a print. If we narrowed these pleats, I think it would make a super durable hinge. I mean, we've already done a TPU hinge, and I think, you know, even a single piece of TPU makes a great hinge, but by having a couple short pleats would make it incredibly durable. I mean, this is pretty much indestructible. Like those other pieces, I can't tear this apart. I mean, sure, it kind of stretches to the point where it bends back on itself, but then it just self-recovers. And because TPU bonds to itself so well, not only is this really, really hard to actually destroy, I think this is probably also water and air tight, even printed only 2 layers thick. So I could see doing a water pump with this, air pump. Again, so many different ideas. Let me know down in the comments what ideas you guys have seeing this, or how you might incorporate this into your own design. Well, I know this week's video was a little bit different, but as always, I really appreciate you guys hanging out in the shop with me for this week's designs and videos, and I really hope I've inspired you in your own designs. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints and more of the engineering side of 3D printing. So if you're into that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.